So I was talking about big data analytics and Hadoop software, which basically is the first software which allows us to handle big data, and a concept called as distributed framework. And we will be learning on setting up a Hadoop environment, on GCP in quick, in fact, no time, less than 5 minutes, you can say. But when I talk about big data, these are all the various challenges that you will have to look at. Storing huge amount of data will be challenging because we're talking about size, right? The name itself says big. So you need a lot of storage space. And processing that volumes of data also becomes very difficult. The cost, that is also another challenge. If you have to set up a big data environment, then it is going to require, right, a lot of infrastructure. So procuring that infrastructure would be a costly affair for an organization. The traditional tools, there are SQL and we have Excel software kind of solutions, which basically are used for processing the data or storing and processing the data. But these tools have limitations. Right? They are designed for traditional data, regular sized data. And also new age systems, they are capable to handle and generate, in fact, unstructured form of the data as well. So dealing with this scenario would be another challenge. And the existing tools, because they have limitations, they cannot handle huge amount of data. So that is also another challenge. And scalability is another very important aspect that you'll have to look at. So if you talk about a business, right, today it might be generating 1 GB per day data. Okay, today it might be the case. But what if suddenly the business has improved and it has gone to, let's say, 10 GB per day? Yeah, if you suddenly see that there is data which is 10 GB, right? So you'll not be able to handle that amount of data, that kind of data, isn't it? So this is where we basically have to look at alternative solutions which can handle this kind of sudden increase in the demand or the business requirements. Right? So that's basically your scalability. These are the challenges, and we will try and look at how to basically deal with these challenges. In order to basically deal with very large amount of data, organizations used to employ, or we generally employ this kind of solution where we try to procure higher configuration softwares, but servers. But the challenge is, beyond a point, there is no server which can actually be purchased. Even if you want to procure, there are hardware limitations. The another point is the cost is going to be non-linear, very, very costly. Servers are going to cost huge, right? This process is called as scaling up, but this is not an ideal solution. And that's where organizations came up with a logic called as horizontal scaling or scaling out. This is called as vertical scaling, whereas this is called as horizontal scaling. So if your requirement can be handled by 2 computers, then combine 2 computers and that becomes your server. So capability of both the servers will be used. If your requirement has increased and you need more computing and storage capacity, then you will combine 2 more. So you'll get total 4 nodes now, or computers now, which all together will help you to process your store and process your data. As and how your business improves, grows, you are also going to grow up, scale up with respect to the demand. But the important point here is, if I have a data which is too big for storing in a single computer, for example, Let's assume that this is a 500 GB hard disk storage server. I mean, a system, local system, which is 500 GB. This is basically the disk size. If I have a 1 TB file, which is twice as the storage capacity that the server has, I will not be able to store into this. Not possible. Practically speaking, here also it is not possible. But can I store here? Individually, it is 500 GB only. But if I combine all the 4 disk storage spaces, I will have 500 into 4. Right? So that means I'll have total capacity of 2 TB storage space. Right? So I will be able to store this 1 TB file into a 2 TB storage space. But how do we practically do that? Right? So what happens in this concept, distributed environment concept, is that we will split this 1 TB file into multiple partitions. We split them. Standard partition size will be 128 MB, and we will store the files here in different systems like this. Right? So total how many? We'll have 128, 128, 256, and 8. Right? Total 8 partitions would be there. So now each server is 500 GB storage capacity server, or your computer is 500 GB hard disk, regular computer. But I'm storing only a file of 128 MB. It is very easy to store this in a 500 GB hard disk. Right? So that's the logic which is employed in big data environment. This is called as distributed. Your data is getting distributed into smaller portions and then getting stored in different systems. Right? So that is basically what happens here. If you see, we are taking this, let's say, 1 TB storage space, and I'm splitting this into 4 parts. Then the logic here is, if one of the server goes down, one of the node goes down, then probably the data will also go. So to ensure that the data loss does not happen, we also use a technique called as replication. Here we have partitioning, here we will have replication. Okay. Combining these two, you will be able to see like this. If I have 1 TB storage space, now it becomes 3 TB. 1 TB is becoming 3 TB. Right? This is a disadvantage, but ultimately you'll have to safeguard the data, right? So if any organization, right, if you ask them, do you invest a small amount in safeguarding your data so the data loss does not happen, then they will happily invest in that. Right? So from that perspective, storage overhead is increasing by 200%. Right? Storage overhead is increasing by 200%, but that is fine. Right? There's no issue because we don't want the data loss to happen. Right? So that's basically your logic here. Right. Now, how do I actually set up a software called Hadoop here? The advantage here is that Hadoop is an open source framework. It's a free and it's open source framework, and it supports storage and processing both for your large amount of data sets by splitting it, right? And the environment that we're talking about is called as a distributed computing environment, right? So that's the logic of Hadoop, and it all began, the software actually was developed by initially Google, because Google has a lot of amount of data and they need a solution to handle all that data. Right? So they came up with a solution and they said, this is what we are using. They gave a name to that approach or software, which is called as MapReduce. This was published in 2004, and a year later, in 2005, two people have come up and enhanced this MapReduce into an operating system. I personally would call Hadoop as a operating system. It's a framework. It's not a database, right? It's not a database software. It's a platform on which you will be able to handle your big data. Right? So imagine Hadoop is an operating system which is basically given for this computer. Right? But what is this server or computer? It is actually a combination of multiple computers which are interconnected and working together so that the end user can have an experience of a supercomputer. For end user, this is the computer. Internally, you'll have various components. Those components are nothing but multiple computers or multiple nodes. Right? So this is your operating system for distributed environment. Hadoop is operating system for this environment. And it contains storage capacity or storage service or module and processing module. This is basically taken directly from Google itself. And then to manage all the resources that we have here, we have a cluster manager, which is called as YAN. YAN stands for yet another resource negotiator. It's called as another resource, yet another resource negotiator. Now, how do I set this up? Okay, there are a bunch of benefits with respect to Hadoop you can see here. It allows you to store and process large amount of data sets. It will allow you to do parallel computing. It's a free software. It can be implemented on your regular computers, regular hardware. You don't need specialized hardware. It is scalable. It is reliable because at any given point of time, your data will always be available. And even in case of failures, Hadoop will handle those failures effectively. Hence, it's fault tolerant as well. Now, this big data environments are used for archiving your data and report generation. That is because it has the capability of write once and read many. That means once you have written something on Hadoop platform, you cannot edit that. Right? It's consistent there. Right? So that's the reason why it is used for archiving and analytical processing purpose. Multiple people can parallelly connect to that data and then they generate their own customized reports as well, because data is going to be consistent. You cannot alter the data. All right. Now, how do we set up Hadoop in quick time? Right? And you'll also be able to use Spark as well in this environment. So all you have to do is go to Google and search for Google Cloud. GCP, Google Cloud. If you click on that, it will take you to this page where you will have to log in. It will ask for you to log in. All you need is a Gmail account, right? And you need to have a simple credit card. If you have these two, then you can set up your environment. The credit card is required to validate your payment mode, and they will charge ₹2. Of course, that will be returned back. So that's the logic. It's very simple, right? Steps that you'll have to follow. Once you come here, it says sign in. You click on sign in. You will be able to log in. Then you can start initiate my free services. And if they they will ask you for payment circle. You just enter your details and that's it, job done. You'll come to this. I will have to go to console. Either you click on the right top corner here, we will see console option, or you can click on this go to console option. You can go through a lot of information that is available here, right? All these are different. These are different aspects, different features or services that you have on GCP. You can go through all these things. Now I'll go to console. Once you go to the console, this is what you will see. By default, there will be a project assigned to you. Okay, this is a project which is created. If it is not created, then it will ask you to create a new project. Just go with the default steps. If you want to change the name of the project, you can change the name, but otherwise go with the default things. Once you come to this particular page, here you see this hamburger menu. This is called as hamburger menu at the top corner here. This one, the circle bar, 3 lines that you see, hamburger. This is the main menu option. And if you click on this, you will see all these different services. So products, compute, serverless storage, databases, applications, networking operations, CI/CD, continuation integration and continuation development. Then we have various tools. We have big data. This is where we need to come. And here I see, right, Dataproc. If I click on this pin, this Dataproc service will come and sit here. You can see pinned option will be there here, and these are the default pinned option. I'm pinning the AI platform and Dataproc and cloud storage. Okay, that's all. This is what you need to do. And if you click on Dataproc, you will see clusters. To start with, there will be an API that you have to enable. Okay, let me show you that. If I search for APIs, you can see APIs and services. Click on that. And here you are going to search for Dataproc. Okay, you can just enable the APIs and services. Click on that, and you say Dataproc and search. Dataproc. This is Google Cloud Dataproc. Wait, what is this? Okay, I think I already have enabled Dataproc, so it is not coming up here. But yeah, so we basically have to come to enable the Dataproc API. To start with, the applications that we are going to use, they are disabled. By default, they are disabled to start with. You will have to enable that particular Dataproc application. Right? And when you click on Dataproc, you'll come to this Cloud Dataproc. You can search for that in APIs, and then you will be able to get this screen. Once it is enabled, only then you'll get the cluster. So you can see Dataproc is the feature which will allow to provision an Apache Hadoop cluster, and then we can connect to those servers as well. Now, Hadoop basically is designed for multiple computers, right? But we can also create a single instance. It's called a pseudo cluster, which acts as if it is multiple computers, right? That's how we are basically setting up here. So all you have to do is create cluster, click on this button, and you'll get the cluster name. You can give any name, but make sure that it shows name must start with a lowercase letter followed up by a 54 lowercase letters, numbers or hyphens, and cannot end with a hyphen. These are the conditions that you will have to ensure you're giving in the name. Then region, you can decide what region you want to put your server 2. See, lot of regions are there, including ASEAN region. You can try and play around. Then we have zones, different zones. You can choose the zone as well. And then what is the cluster type that you want to set up? So this is a standard where you will have one master and multiple workers. All these worker nodes are controlled by this master. By giving instructions, the master will manage all the worker nodes. Right? You can also use this logic, or you can set up a single node which acts as if the single node is going to behave like multiple computers, though physically it is not existing. Provides one node that acts both as master and as worker nodes. So it is good for proof of reading or for small scale processing. For your practice purpose, I would recommend go with a single node instance. Then we also have high availability. This is for organizations, if enterprise level, if they want to ensure that services never go down, they can have high availability setup also. I'm going to go with this standard. I'm going to show you what needs to be done. Auto scaling, if you want to scale up or scale down, you choose the auto scaling by giving the policy here. I have none because I'm not given any policy for this. Then this versioning is the operating system. If you click on change, you can see these are the different operating systems. CentOS, Debian, Ubuntu. These are the 3 Linux operating systems which are currently given for these instances. You can choose any one of this. By default, it is Debian that is got selected. Then let it be there. Then you have to enable component gateways. You have to click this. If you don't click this, then user interface options will not be given. Everything will be in a terminal mode only, right? Black and white. Then if you want to work with Jupyter notebooks, then you can click on this, or any of the web application that you want to use in big data platform, you can choose that. There are interdependencies. You basically have to read this interdependencies while you are trying to select any of your web UIs. All right, that's it. In this setup cluster concept or part, this is all we need to do. Then configure nodes is where you are going to define the computing capacity. There are different servers. I'm choosing the least server, N1 first generation, and here also I'm choosing 7.5 GB. That is the least server that I have, and this is for your master node. The disk storage space also you might want to play around with. You can give 500 or 50. Then I have worker nodes. We have set up 2 worker nodes. Replication factor is 2. We have defined 2 worker nodes. You can define as many worker nodes as you want. You can put 200 there or 220 there. Right? This storage space I'm reducing. I'm having only 2 worker nodes. And these worker nodes also are from the same family of the server or compute engine. That's it. We don't do anything else in any of these options, and then click on create button. That's it. You just click on create button, and this is going to spin off a Hadoop cluster. That's it. Sit back and wait for this to provision. It will probably take not more than 3 minutes. So it is going to initiate 3 servers. Out of that, 1 server will be master and 2 servers will be worker nodes. If you click on the cluster here, it will take you to the next details, further final details, and you will be able to see the monitoring. It is still provisioning. These are the various jobs that are running. None at this stage. And then VM instances. Look at that, 3 virtual machines are created One is your master, two are your worker nodes. So MW0, W1, that is basically the naming right format that Hadoop GCP Hadoop uses. And web interfaces, we have enabled web interfaces, right? So if you click on that, these are all the various web interfaces that you can actually use. Right? Now, if you see here, only for master node, which is also edge node, or you can say checkpoint node in this case, will have access directly given. And all you can do is click on this button, open in browser window. That's all. And you will be able to access your server. You'll have to connect via SSH. It will take probably a minute. Provisioning, yeah, it's still doing. And here, voila, gone. We logged in. So if I say Hadoop, it may not work at this stage. Yeah, I'll just try to increase the font size. I'll say Hadoop. Yeah, it's not. Yeah, I think it is installed. So I'll say version. You can see that's the command. So Hadoop space version, if you do, it basically tells you what is the Hadoop that you have installed. Job done. You're brought in a Hadoop cluster in less than 3 minutes. We initialized the Hadoop cluster at 7:01. Now it is 7:03 and your cluster is ready. Right? You're able to access the cluster. Though it is still saying provisioning because it is trying to set up the all the finer things, related services and all that. But yeah, we have our Hadoop server ready. On the Hadoop server, big data platform, this Hadoop cluster, you also have Spark installed. If anybody wants to use Spark, Spark is also given. Look at that. You just install, initialize PySpark, and you will get PySpark here installed. And you will be able to use this PySpark here. Oops. Yeah. See, Spark is also available. So you don't have to waste time in setting up things and all that. And once you are done, let's say you are now using, right, your server. Once you are done with your tasks, right, you can simply end the session, right? Here you'll see running, that is Hadoop server is up and running now. But if you don't want, if you're done with your work, then you can simply say stop. This will stop cluster. You will not pay for these VMs while the cluster is stopped, but you will continue to pay for other resources associated for the cluster. Like VM instances are associated, you're blocking them. So you'll have to pay for that, but cost will be minimum. But if you are deciding that, no, I don't want to pay anything, I'm done with my entire installation, then you can simply use delete button if you're done with your task, Hadoop task. Whatever the task that you want to do on the server Hadoop cluster, complete that, and then once you're done, you can say delete. But this delete will not be sufficient, right? You will still be paying for related tasks. Remember, that's the message that we have seen. So here, if you click on the hamburger menu, right, or if I have to show here, storage staging bucket is created. That means we are using Google storage service. That is, if I scroll down here, under storage, you see Google storage. I right click and say browser. Right click on this browser and open a new window. These are the storage devices on GCP, and Hadoop cluster is automatically created 2 folders, temp directory and staging directory. So if you're done with your Hadoop cluster, See, now it is stopped, but if you don't want this, you can simply say delete. Confirm you want to delete? Yes, I want to delete, and it will hardly take any time to delete also. But along with this server deletion, you also have to delete the buckets to make sure that you don't get billed. It will ask for the confirmation and just give and then say yes. So Hadoop cluster is deleted. Now storage buckets are also getting deleted. Now, what is Hadoop? What is big data, right? If you want to learn more on these concepts, then in the LMS, everybody has recommended videos assigned to you. If you come to the videos section, to that particular folder in LMS, you will see recommended videos. Under the recommended videos, the second option is big data. If you click on this, it will open like this, and you can see here, this big data is the entire, right, big data concepts are discussed in detail in these videos. Total 16 videos are there, and in these videos you'll basically get to know Hadoop. You'll basically learn Linux commands. You'll also learn Hadoop installation on standalone instance as well, offline, right? Offline instance also, and then configuration. Then we look into the commands. You also have additional tools like Pig, Hive, HBase, Scoop, right? All these things, and Spark as well. Right, so you might want to go through these recommended videos to understand what is Hadoop and all that. Okay, so that's with respect to the webinar, and you can see here we have created a Hadoop cluster in less than 3 minutes, and then once your work is done, if you don't want to get billed, you can simply delete your entire cluster. It hardly took any time, right? So this is basically how you deal with Hadoop clusters on cloud platform. This is GCP for you guys. All right, so that's all I wanted to convey for you people this week. And yeah. Just make sure that you're learning these concepts, refer to the recommended videos. All right. Yeah. Hope you have learned how to set up the Hadoop cluster, and hope you're going to use these concepts and practice well. All right. Thank you so much, and enjoy the rest of the evening, friends. Good night.